my students, this is Bijay sir, your chemistry teacher. Today I have made a video to discuss the remaining part of the previous video. In previous videos, we had started discussion on the last and fifth types of chemical reaction, that is redox reaction. And in the last video, we have learned up to fifth rule regarding the calculation of oxidation state or oxidation. So, today we shall start with rule 6. Rule 6 is in any compound or in any ion, the oxidation state of hydrogen is usually plus 1. We shall write the rule 6 as in a compound or an ion, the oxidation state of hydrogen is equal to plus 1. Example, H2O, hydrogen plus 1, HCl, hydrogen plus 1, HCO3 minus, this is ion, hydrogen plus 1, H2O2, hydrogen peroxide, hydrogen plus 1, HClO3, hydrogen plus 1, etc. Now, in a compound or an ion, the oxidation of state of hydrogen is plus 1 in water, plus 1 in hydrochloric acid, plus 1 in bicarbonate ion, plus 1 in hydrogen peroxide, plus 1 in hydrogen chlorate or chloric acid. Right? But there is an exception. In a particular type of compound, the oxidation state of hydrogen is minus 2. And that particular type of compounds are metallic hydride. We have discussed the list of reactive metals in reactivity series of metals. Usually the metals which are placed above hydrogen in the reactivity series. In the reactivity series, some of the metals we have placed above hydrogen, some of the metals we have placed below hydrogen, and also we have learned the metals which are placed above hydrogen in the reactivity series are more reactive than hydrogen. Means they are able to lose their electron more easily compared to the hydrogen. So, such all metals forms hydride to combine with hydrogen, called metallic hydride. In metallic hydride, the oxidation state of hydrogen is -1. Exception. In metallic hydride, the oxidation state of hydrogen is -2. And examples of these metallic hydrides are sodium hydride, potassium hydride, calcium hydride, magnesium hydride, etc. Sodium hydride, NaH. So we have read sodium is alkali metal, its oxidation is +1, its oxidation state is -1, because the total sum of oxidation states of all elements in a compound is 0. Potassium hydride KH +1 -1. Calcium hydride CaH2 +2. This is alkaline earth metal. Hydrogen -1. Magnesium hydride MgH2 -1 +2, etc. This is 6th. Now, the rule 7. In sulfides, the 7th rule is for the element sulfur and for a particular class of compound of sulfur. Sulfur forms several kinds of compound: sulfide, oxides, sulfate, sulfite, thiosulfate, etc. We are in the 7th rule. We decide the chemist decide the common oxidation state which sulfur possesses in a particular type of its compound, that is called sulfide. The oxidation state of sulfur in sulfide. 7th rule we shall write. The oxidation state of sulfur in sulfide is equal to -2. Example: think the name sulfide, H2S, hydrogen sulfide, Na2S, sodium sulfide, K2S, potassium sulfide, ZNS, zinc sulfide, PBS, lead sulfide, etc. Now, 8th rule. Halogen is a family of elements which are placed in the 7th A group of the modern periodic table or group 17 of the periodic table, just before just before the inert element, group of inert elements. Just before neon, fluorine is placed. Just before argon, chlorine is placed. Just before krypton, bromine is placed. Just before xenon, iodine is placed. So, fluorine, chlorine, bromine, iodine and statine. These 5 elements are called halogens. This family of element is called halogen. And it forms the most popular and common type of compound, which are called halides. For example, sodium chloride, sodium bromide, sodium iodide, potassium chloride, potassium bromide, potassium iodide, calcium chloride, calcium bromide, calcium iodide, etc. In halides, the oxidation state of halogen is minus. The rule 8 we shall write. In halides, the oxidation state of halogen. The oxidation state of halogen, like chlorine in chloride, chlorine in chloride is -1. Example, HCl hydrogen chloride -1, HBr hydrogen bromide, HI hydrogen iodide, Ki potassium iodide, AgBr silver bromide, AgCl silver chloride, CaCl2 calcium chloride, AlCl3 aluminum chloride, etc. Except fluorine, which is the first member of halogen family, the oxidation state of all halogen may change by changing their types of contact. But due to the highest value of electron negativity, due to the highest electron negativity value, the oxidation state of fluorine is always -1. The oxidation state of other elements may change due to fluorine, but fluorine always possesses the constant oxidation state, that is -1. In note we shall write, in a compound or ion, the oxidation state of fluorine is always minus 2. Is always minus 2. Now, the rule 9 is the oxidation state of oxygen in any compound or in any ion is usually minus 2. As you know, oxygen usually gains 2 electrons, and to convert itself into oxide ion, that is O2 minus. In a compound or ion, the oxidation state of oxygen is equal to minus 2. Example, any common compounds of oxygen you can take. As example, H2O, oxygen minus 2, water. H2SO4, oxygen presents minus 2 charge. Na2O, sodium oxide, oxygen minus 2. Al2O3, aluminum oxide, oxygen minus 2. Fe2O3, oxygen minus 2. Cu2O minus 2. CuO minus 2. But in the case of rule 9, oxygen other than minus 2 oxidation state, oxygen possesses 4 other kinds, 4 other values of its oxidation state in different kinds of compound. So they are listed as the exception of oxidation state of oxygen. So let us discuss the exceptions of oxidation state of oxygen. Exceptions. The first exception is in peroxide. The oxidation state of oxygen is minus 1. In all compounds whom you give the name peroxide, the oxidation state of oxygen is minus 1 for those oxygen atoms which are the part of peroxide bond. We should know what does peroxide mean. The peroxide is a bond between two oxygen atoms. In peroxides, the oxygen state is -1. We shall define peroxide, the compounds in which at least two adjacent oxygen atoms are linked by a single covalent bond are called peroxide. I would like to define peroxide here. Peroxides are the compounds in which at least two adjacent oxygen atoms are linked by a single covalent bond. Now we should take some example of peroxide. The most popular example is H2O, O2. H2O2, hydrogen peroxide. If you will write its structure is H single bond O single bond H. Here hydrogen, the oxidation state of hydrogen is +1, and these two oxygen are the these two oxygen are the oxygen of peroxide bond. This is called peroxide bond. Other example is Na2O2, sodium peroxide. Sodium peroxide, you will write like this: Na plus, O single bond O, Na plus, and here is -1, -2. The next example of peroxide is chromium peroxide, whose formula is CrO5. Name is chromium peroxide. If you will write its structure, chromium here forms 4 bond with a pair of peroxide bonds. Here 5 oxygen atoms are there. You see, look into the structure of the chromium oxide. 1, 2, 3, 4. These two pair of oxides are the oxides which are the oxygen which are linked by peroxide bond. Right? Because single covalent bond is peroxide bond between at least two oxygen atoms. But this fifth oxygen is not the peroxide because it is linked by double bond. Here the oxidation state of oxygen is common oxidation state of oxygen, that is -2, but these 4 oxygen possess -1 oxidation state, etc. This is the first exception in the rule regarding the calculation of oxidation state of oxygen. Now the next exception B in OF2, or you may write this compound as F2O. It is named as oxygen difluoride. In oxygen difluoride, the oxidation state of oxygen is equal to +2. You need to learn this exception carefully. Here the oxidation state of oxygen reversed as its common oxidation state, -2. The common oxidation state possessed by oxygen is -2. But in oxygen difluoride, this is only one compound, where oxygen possesses +2 oxidations. And this is due to fluorine, because we have read in the note when we discussed the oxidation state of halogen in halides. The fluorine always possesses -1 oxidation state. So you may calculate, the total sum, the algebraic sum of oxidation states of all elements in a compound is equal to 0. You may calculate here the oxidation state of oxygen if you have learned the oxidation state of fluorine. The oxidation state of fluorine is -1. Use -1 into 2 and let the oxidation state of oxygen is X, and the sum will be 0. Therefore X will be +2. So this is the +2 oxidation state of oxygen in fluorine or in oxygen difluoride. Now, due to fluorine, there is another exception of the oxidation state of oxygen. Fluorine may combine with oxygen to form fluorine peroxide in F2O2. This is called fluorine peroxide. The oxidation state of oxygen is equal to plus 1. Again you may calculate it. F2O2 is equal to 0 and fluorine is minus 1 always. The minus 1 into 2 oxygen. Let the oxidation state of oxygen per atom of oxygen is X. Therefore it will be 2X is equal to 0. So 2X is equal to plus 2. Therefore X is equal to plus 2. Right? And there is one exception which we have to discuss is superoxides. Alkali metals, we have learned alkali metals. The metals which are kept in group first A of the periodic table are called alkali metals, and they are lithium, sodium, potassium, rubidium, cesium and francium. Here francium is a natural radioactive which usually does not take part in the chemical reaction. Therefore, for alkali metals, lithium, sodium, potassium, rubidium and cesium, 5 alkali metals form superoxide. In the next exception, we shall write in superoxides the fourth exception is in superoxides. The superoxides you will learn LiO2, lithium superoxide, NaO2, sodium superoxide, KO2, potassium superoxide, RbO2, rubidium superoxide, and CSO2, cesium superoxide. The oxidation state of oxygen is equal to minus half. You may take any of the 5 superoxides to decide the oxidation state of oxygen in it. So suppose we take potassium superoxide K2O. It is a compound, therefore the total sum of oxidation states of the 2 elements will be 0. And we have learned the oxidation state of alkali metals remains constant, that is plus 1. The potassium plus 1, and let the oxidation state of oxygen is X per atom of the oxygen. It will be 2X is equal to 0. So 2X is equal to minus 1, therefore X is equal to minus 1. This is all about the exceptions under the rule of oxidation state of oxygen. Now, how many rules we have discussed? 9. The 10th rule is the basic rules we have discussed. Now, in the 10th rule, I would like to give you some ideas, some tricks which will help you in practicing when you will practice to calculate the oxidation states of different elements asked in different questions, these rules which I am going to discuss with you under rule 10 is just a ready-made rule and just a trick for you. The rule 10. Under rule 10, we shall write 3 parts. One. First, A. The oxidation state of some of the elements may be different in their different compounds. So to check that the oxidation state of the particular element, we should have the idea of the range of their oxidation state. The minimum oxidation state of any element is equal to how much? The minimum oxidation state of an element is equal to its group number. Group number in the periodic table minus 8. Group number minus 8. How can we understand this rule? Take an element oxygen. Oxygen belongs to group 6A in the periodic table. Therefore, minimum oxidation state of oxygen is equal to 6 minus 8, that is minus 2. Right? And the oxidation state, maximum oxidation state of an element the maximum oxidation state of an element is equal to its group number. Group number, please do not confuse with the group number as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18 as per the guideline of IUPAC. Here we are talking about the group number as mentioned by Mendeleev in his book and followed by mostly in the modern period, which we used to write in Roman, like this one, 6A. The maximum, therefore maximum oxidation state, the maximum state oxidation state of oxygen is maximum oxidation state of oxygen is 6, that is plus 6, means the oxidation state of oxygen may be from -2 to +6. Right? Now, in the third part, I would like to provide you some common molecules and some common ions with their oxidation state, or which already we have discussed under the rules, the total sum, algebraic sum of oxidation state of all elements in a compound, in a molecule is 0. But some molecules are there which comes as a whole molecule in a particular type of compound, where you will feel convenient learning that common molecules which are used in the formation of a particular compound as a whole molecule. The oxidation state of some important molecules and ions I would like to write for you on the board. The oxidation state of some important molecules and ions are written below. Molecules, ions, H2O as a whole 0, NO2 as a whole 0, CO as a whole 0. Sometimes CO2 is also used as a whole molecule in any particular compound. Ammonia, NH3, NO, 0, etc. And some common ions. The first of all, I would like to write in the list of ions 2 ions, CO and N, which create confusion among the students. Whenever CO is used as ion, the plus is mentioned on the +1. NO, when used in any compound as NO ion, plus is mentioned on NO. We shall use +1. Means CO sometimes used as molecule, sometimes used as ion, depending upon the nature of compounds in which it is used. And next, OH minus, -1 as O4 2 minus, -2, NO3 -1, NO2 -1, S2O3 2 minus, -1, C2O4 2 minus, -2, PO4 -3, PO3 -3, N 3 minus, -3, C minus, about the rules regarding the calculation of oxidation states or oxidation. Dear friends, I hope you have understand all the rules discussed by me. To have the concept of oxidation and reaction, and to have the concept to solve all different kinds of reaction, all different kinds of questions asked in the examination from oxidation and reaction. I would like to advise you, please read all these 10 rules as carefully as so that these rules do not miss. These rules must not escape from your memory. Please keep all these rules clearly, sincerely in your memory. What will happen then? Then you will enjoy the next video which I shall provide for you. In the next video, we shall discuss, and the next video will be very interesting for the students who will keep all these 10 rules in their memory. The next video will be very interesting for them. So I want you all readers, you all viewers, and all my dear students, please learn all these 10 rules which I have provided. Dear friends, now we are going to finish our first chapter, chemical reactions and equations, in 2 or 3 videos. And all these videos which I shall provide you will be based on the oxidation reduction. So stay at your home, stay safe, read carefully, and today I would like to advise you, I would like to request you to share all these videos with your friends, and if any of you have not subscribed the channel, please subscribe my channel so that you can have my video just after uploading the video in the YouTube. That will be more beneficial for you. Many of the students have called me, sir, I have not got your video from where I can have. That is why I am requesting you all, please, if you are interested with my teaching, if you would like to continue reading with me, please subscribe the video so that you will have my you will have my video just after the upload. Okay, thank you.